sort of leverage to help our customers work with our imagery. And of course, we're using Kubeflow to do it all. So recently, I've been working a lot with Kubeflow pipelines, and we found lacking sort of the ability to nest pipelines in a way that's more abstracted for a user so that they could call one pipeline or multiple without having to duplicate code. And so that's really what we're looking for here, is to simplify that interface for our pipelines, and also to prevent users from passing in the wrong parameters to pipelines. Our users are not maybe the most adept with utilizing this code, like we've heard in other talks. It is a little complicated. So as engineers, we're trying to make it a little simpler for them and then duplicate the code in the process. So how are we going to do that in this talk? We thought of some interesting ways to deduplicate code using Jinja templates, which is a templating language used in other projects. And then also we wrote a little wrapper, and all this code is on GitHub and freely available. And that wrapper allows us to nest pipelines and also to leverage Pydantic, which is for schema validation on the inputs of those pipelines. So we think that's a good solution to the problem of, how do you deduplicate code and make it easy for users to use? So what I'll be presenting today is I have 3 examples of components that we've templatized. And then I also have a simple nested pipeline to show how it works. Now it's, like I said, a simple example, but hopefully we all can see the use case and the reason for this nested pipeline. So if we go to the next slide, please. We'll get to the first component, which is near and dear to everyone's heart, that is a machine learning engineer, and it's how do you download from a URL and ingest it into Kubeflow pipelines? I'm sure most of you have written this component, but we took it a step further to say, can we download multiple artifacts and then treat them as different things? So this example is it's downloading a user and it's treating it as a dictionary. And you can see on the left, there's the actual pipeline run. It's downloading that URL at the top, and the output is the user dictionary at the bottom, which is just a JSON dictionary. So if you go to the next slide, we can see how this template works. It's sort of a factory pattern where you pass in what are the parameters that you want to have control over, and it could be any number of them, and they could also be of any type. So this it doesn't bypass the Kubeflow pipelines components in the V2 SDK, but it augments it. It makes it a little bit more flexible, so you don't have that duplicate code between, I want to download a data set versus I want to download a pipeline parameter. And on the left is the simple Python code. It's really just a curl for each of those. So if you go to the next slide, we'll look at the next step in this pipeline, which is a component for parsing a dictionary. Now, when we started nesting pipelines or encapsulating these pipeline parameters in a dictionary, we found that we had to, parse those dictionaries in order to pass them to follow-on components. So this is that component. And it's, again, templatized using Jinja so that you can pass in a dictionary that's the name of the pipeline parameter and the type for each of them. So here we're breaking apart this dictionary into its components: the user ID, the title, and the completed field, and they're all typed. So if you go to the next slide, we could see how the template for this one works. Very similar to the download component is this parse component. Again, you pass in those names of the pipeline parameters along with their types, but you also pass in a dictionary that is the dictionary you want to parse, and it outputs to each individual file in Kubeflow pipelines the contents. It's cool and powerful because you can do this on the fly as you create pipelines without having to continuously add more and more components to your code base. So next slide, please. We'll see that this next component is the opposite of the parse, where say I have a bunch of pipeline parameters that I want to combine into a single pipeline parameter. That's what this component is used for. Again, it's very similar to the two previous, where you pass in this dictionary that has the pipeline parameter names and types. But this time, instead of passing in the dictionary from the download, we're passing in the outputs of the parse. And so it's really just a, parse it all and then put it all back together to show how this component would work. So on the next slide, we'll see the template for this, which is one previous, please. This template again is almost identical to the previous, which is the parse, but instead of passing in the dictionary, you're instead getting out the dictionary. And on the left, there's the pipeline code, the Python code for doing that combined logic. So between these three components, I think these are nice examples of how to use Jinja as a templating language. And also they're the nice reusable components or component factories. And on the next slide, we'll see how the factory portion of this works in Python. If you go to the next slide, please. This is how the factories get generated from the Jinja template. You really just, you render the template into text, which creates your YAML file for your component, and then you load that component from text into a Kubeflow pipelines component. So on the next slide, that's the Jinja portion. If we go to the next slide, we'll see a nested pipeline. Now this is the pipeline run, which isn't that, you can't tell it's a nested pipeline from here, but if we go to the next slide, we'll see the code and show how it gets nested. So if you go to the next slide, please. You'll see on the left the two pipelines. The top one is that parse and combine, and then the bottom one is a nested pipeline that calls it. Now you'll notice there isn't a pipeline decorator on these, and instead what we've done is we've created this wrapper called pipeline with a capital P, and that pipeline wraps it in the necessary decorator, and it also adds the ability to specify a Pydantic schema for input, so you can do your Pydantic validation, which is really powerful in and of itself, as an input to your pipeline, and then use these nested pipeline functions as you see fit, along with all these parse and combine components. So I know this is a contrived example of what a nested pipeline is capable of, but we use this internally to our team at Maxar to do larger pipelines and to manage our code debt as we make more and more pipelines with more and more components. So on the next slide is I think the last slide. I left this time for questions that anybody might have, but we also have a GitHub repo with all of this code. Like I said, it's freely available. And I'll post these slides so that you could click that link in the top right to the Slack. And of course, I'll use this public forum to say, of course, Maxar and the applied machine learning team is hiring. We're, of course, looking for data scientists, machine learning engineers, and machine learning operations people. So with that, if there's any short questions now, that'd be great. Or, of course, please contact me over Slack, and I'm happy to answer any questions there.